We are covering the geometry of circles, a key component of the AFOQT math knowledge subtest. This section tests your direct understanding of mathematical principles, and circle problems are a frequent and reliable way the exam assesses your grasp of geometric properties. Let's start with the basics you must have memorized. Circumference is the distance around a circle, calculated as c equals 2 times pi times the radius, or 2 pi r. The area, which is the space inside the circle, is a equals pi times the radius squared, or pi r squared. A common trap on the AFOQT is providing the diameter instead of the radius. For instance, a question might ask for the area of a circle with a diameter of 14. You must remember to have the diameter to get the radius, which would be 7, before plugging it into the area formula. A equals pi times 7 squared, giving you 49 pi. Confusing the area and circumference formulas under pressure is a frequent error, so lock those in. Now let's move to parts of a circle. The length of an arc is a fraction of the circumference. The formula is the central angle theta divided by 360, multiplied by 2 pi r. Similarly, the area of a sector, which looks like a pizza slice, is theta divided by 360, multiplied by pi r squared. An exam question might state, a radar with a range of 10 miles sweeps an angle of 90 degrees. What is the area of the region it covers? Here, the radius is 10 and theta is 90. The calculation would be 90 divided by 360, which is 1/4, times pi times 10 squared. This simplifies to 1/4 of 100 pi, or 25 pi square miles. The exam tests your ability to apply these formulas quickly and accurately. Another critical concept is the inscribed angle theorem. An inscribed angle, which has its vertex on the circle, is always half the measure of the central angle that intercepts the same arc. A typical AFOQT question might show a diagram where a central angle is 80 degrees and ask for the measure of an inscribed angle subtending the same arc. You must know to divide by 2, making the answer 40 degrees. They might also reverse it, giving you the inscribed angle and asking for the central angle, forcing you to double it. A special case is an angle inscribed in a semicircle. It is always a right angle, or 90 degrees. Finally, you must understand the relationship between a tangent and a radius. A line tangent to a circle touches it at exactly one point and is always perpendicular to the radius at that point of tangency. This property is crucial because it often allows you to create a right triangle, bringing the Pythagorean theorem into play to solve for unknown lengths in a more complex diagram. To help remember the two fundamental formulas, use this mnemonic. Cherry pie is delicious, apple pies are too. Cherry pie is delicious stands for circumference equals pi times diameter. Apple pies are too stands for area equals pi times r squared. Memorize this to avoid swapping the formulas during the exam. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.